Hey guys, hey guys, welcome back to another video. So today I'm going to be showing you guys how to find E equals mc squared, which is Einstein's famous formula for energy in relation to mass and the speed of light. So for this program, the speed of light for us is 299,792,458. Okay, I took this number from Google. I didn't measure the speed of light myself, so I wouldn't be sure. Maybe this value is a little higher, a little lower. Usually, like in school, they tell you 300 million. So, but I'm just going with the value Google gave me. So, yeah. So to start the program, I'm going to include our IO stream, which is our input output stream. Include our IO manip, which is used for this, which is for used for fixed and set precision. The reason we do this is so we have a precise two decimal places, because I'm trying to leave this program to two decimal places in case we get into two decimal places where like I don't want it to have like more than two decimal places, okay? But you guys don't even need to include this, but it's an option. Like you guys could just run the program without this. You could just comment this for you guys, show you guys. Just let me put this here. And just put this here. Same thing, but I don't know. I'm copying it twice. But let me put this here, comment it out, and let's do this real quick. Show you guys how the program would run without this and this. Let's run the program. So enter mass. Let's say 10. I'm gonna say 0 since we're gonna find the mass. So without the fixed precision, this is how the value will look like. We just have a plus 17 because there's like 17 more digits. You know what I mean? To be visualized. But I'm gonna just do this real quick. Just put this back. No point of copying it earlier, but yeah. So now without the fixed precision, I mean with the fixed precision, this is the difference you're gonna tell. No, it's not, bro. Just put 0. But here it's the energy of the object is da da da. This is the joules right here. You know what I'm saying? So yeah, so this is what happens when you put a fixed. I mean, when it's fixed, it shows the entire number. So yeah, so this is where we need to include the library to use fixed, which is ion manip or IOMANIP. So this is we include this for the header for set position as I comment there. But we're gonna be using namespace std, so we don't have to write this, which is our standard namespace library. You don't have to write this in front of this, in front of this, every line of code. This is why we include it at the top. And we're going to be using a void function. I'm going to call it EMC. It's going to take in a double mass value and a double energy value. Whichever value is 0 is the value we're going to be like what's it called looking for. So for example, if energy is 0, we're going to be looking for the mass. But if mass is 0, if mass is 0, we're going to be looking for the mass, and if energy is 0, we're going to be looking for the energy. We're going to be using the value I told you, the speed of light I took from Google, so this could be a little lower or a little higher, okay? But usually in textbooks back in high school it was like 300 like million. So yeah. So if mass equals 0, we're gonna have to see. We're gonna see how the mass of the object is fixed precision that are to two decimal places. Okay. Energy. What's it called? Over what's it called? Mass squared. Okay. So energy. Sorry. Energy over speed of light squared. Okay. And the second one is if energy equals 0, so we're going to be finding the energy of the object. The energy of the object is fixed to set precision. This is the final mass, by the way. Set precision to two decimal places is going to be mass times the speed of light. Okay, this is speed of light. Okay, multiplied. What's it called? Squared. Okay, so mass times speed of light squared. I'm going to get the answer in joules. Here it's going to be in kilograms. We're going to be using kilograms and joules. Okay. Then our main function has two double variables, which has like two variables. Two double variables. So we're gonna have energy and mass. That's why we just put a comma instead of just saying like instead of just writing it like this. You know, what I mean, again, double it. again. You don't have to do that. Just have to do it like that one time. You know what I'm saying? Just like that one time. So yeah, and it's like easier like that. So we're gonna see how it enter the mass of the object. Just like zoom the code a bit so you guys can see it a little bit. So we're gonna say see how it enter the mass of the object. Okay, we're gonna say constant input mass. See how it's the energy of the object. Constant input energy. So whatever. Okay, there's a problem here. But whatever value is zero is the value we're looking for. So if mass is zero, we're gonna be looking for mass. If energy is zero, we're gonna be looking for energy. Okay. So yeah, I'm just gonna run the program one more time for you guys just to check it out again, so I didn't mess up the code or anything like that. So I'm gonna have like a let's just say this time let's try to find the mass. Okay. Let's say 500 joules, 5,000, 50,000 joules. Still, it's too insignificant, so we're just gonna have to go a higher value. I'm just gonna type in a random mass. Like I'm gonna like that. Okay. So oh sorry, I mean joules. My bad. I'm gonna like go like da 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 da. So the mass of the object is lower value, so this is the mass of the object. So that's how it works, guys. Thank you for watching this video, guys. I'll see you guys in the next one.